Howdy, class. Hope you're doing well, and I hope you are approaching the end of the semester with confidence, especially in this class. We've done some great things in learning Python. We've coded some great projects. We've got a few more great things ahead. So congrats on hanging in there and making it almost to the end of the semester so far. We started out with 35 in this class and we're down to 19. So you lucky 19 are the ones that hung in there and decided you wanted to learn how to code. So I appreciate that. All right, today we're looking at object-oriented programming in Python. And if you haven't heard of object-oriented programming before, perhaps you aren't coming into programming with the previous knowledge from, let's say, C++ or another programming language. What object-oriented programming is in a nutshell. First, make sure to read the book. I'm supplementing the book, but I'm not training or providing training, in substitution or in lieu of the book. So make sure you do the reading. Object-oriented programming for us is basically the ability to use a blueprint to create objects. So what do I mean by that? Well, a great analogy is the old blueprint and a house idea. If we have a blueprint on a scroll here, and it tells us, the ways to go ahead and build a house, well, we can use that blueprint and apply it to a construction activity and actually then go and create a nice house. And if my drawing wasn't so bad, that would actually look like a house. Now, it doesn't end there, though. With a blueprint, we don't necessarily just get to create one house. We can actually use that same blueprint and create a second house and a third house and as many houses as we want, all based on this original blueprint here. And it's the same concept in object-oriented programming. We're going to provide a blueprint, and in object-oriented programming terms, that blueprint is going to be called a class. It's almost like we're creating a programmer-defined entity. It's like a variable, but it is going to contain a lot more information than just a simple integer variable can hold. So we use this blueprint, in our case, a class, and then from here, we're going to derive, a blueprint. We can make houses. Maybe if it's not a blueprint, or maybe it's just a schematic for a car, we could use that and create many different cars. And in object-oriented programming, we'll take a class and we will make many, many instances of that class. Now, what is an instance of the class? Just like a house is an instance of a blueprint, an object is what we call an instance of a class. So there's where that term object, as in object-oriented programming, comes from. Every instantiation of a class is an object, and we can reuse the class over and over and over to create as many objects as we want. Now, the beauty of object-oriented programming is that when we have an entity, and I'm going to call this an object here, when we have an object that we've created, and this is just going to be a normal variable, like we've created like an int age. We've created like a string name. Well, let's say that our class is a car class. And it's got a lot of definitions around it that kind of define, well, what does a car mean in programming? And the way we would then declare an object is, rather than an int or a string, we would just call it called car and then give it a variable name. So my car is going to be our variable name here. And creating an object is that simple. We've got a few more little steps to do, but it's essentially this simple. Now, an object in object-oriented programming is powerful for a number of reasons. One is the idea of encapsulation. So what does that mean? Well, it means that all of the data that the object will ever need is going to be contained inside the object. It's going to have its own private variables that no one can mess with. It's just the objects to mess with. And no one else can come in unauthorized and try and alter them. So encapsulation lets us take some data and then encapsulate it, wrap it around a large envelope, and protect and hide that data. So it's just held within the object. So an object will consist of data. So you can see here that, well, what kind of data would that mean? Well, you know, if we were creating a car class, well, some of the data attributes that might pertain to a car class might be, well, say the number of wheels or the vehicle's make and model, the number of doors, the horsepower, you know, it can be many, many attributes. We could go on and on. Hey, there's my dog. Everyone see Pepper? There's Pepper. Say hi. She's just checking in on us. By the way, if you're watching this video and you see that I just gave a shout out to my dog, why don't you email me with the dog's name and I'll give you a point of extra credit. All right, encapsulation means that its data is going to be contained, but the real power in object-oriented programming is that an object not only will have data, but it'll have methods. What are methods? Well, those are mini functions that are part of the class, and they pertain only to that object. So like a car might have some methods. A car's method might be something like accelerate or go on a trip, and that will add some mileage, or maybe perform maintenance. You know, any kind of those car-related activities we can create as a method. And in the demo that we'll see here in a little bit, we'll have a method that's basically, hey, the car went on a long trip and now we need to update the mileage. So it's going to have an update mileage or go on a trip type of a function where we give it some data and it'll update the car's mileage. So this is encapsulation. All of the data and all of the methods that operate on that data are contained within the class, within the object. And that's the beauty of object-oriented programming. The other part of object-oriented programming that Python supports is this idea of data protection. Let me write that down for us, data protection. And this means that we are going to secure this data so that no rogue code can come in from the outside and try and hijack, or even worse, try and set the data in ways that are unauthorized. We will work our code so that only authorized activities can come and access our class data, much less update our class data. So this is a brief introduction to object-oriented programming. And let's keep going on that idea here of a car. How could we create a class based on a car? Well, it's going to be fairly simple for us. We will start with this class definition. And this definition starts at the top of our code. We'll define this above the main function. And the keyword is class. And the name of our class car, by manner of convention, will always be capitalized. It's a global programming best practice to capitalize the names of our classes. And that's to help us distinguish them apart from variables, which traditionally do not start with a capital letter. So if you see a capital letter, you know you're dealing with object-oriented programming. So inside this class car is where we would put in code here pertaining to data and methods. What would the data look like? Well, we could probably describe car attributes quite easily with the make, the model, the year, the color, the mileage, the horsepower, the number of doors. Is it a hatchback? I mean, we could go on all day. So for our purposes, in the code that I'm going to demo here, we'll just have 4 attributes: make, model, year, and mileage. And then for our methods, we won't have any right now. I'm going to add some in a little bit as we go through this demo. But for right now, we'll just do the data attributes and see how we can successfully code those. The way we do that is we start with class car. And every class has what's called a constructor. This is going to be a mini function, a method. And anytime we create a car object, this constructor function automatically gets called. And it's going to run this code. And traditionally, what a constructor is going to do for us is initialize some or all of the class's private member variables or data attributes. The book describes them as data attributes, class attributes, private member variables are very common also, or class member variables. So I'll be using all of these terms here. Well, the way we do that, we're going to have to, we'll define basically the initialization routine here with creating a miniature method inside our class here. And the way we'll do that is with this, we'll do a def, and then our init, I-N-I-T method is going to have 2 underscores before it and 2 underscores after it, just like that. It always takes 1 argument for now. We can add more, but it'll always have this minimum argument of self. And self is basically a pointer. It's a pointer to your own object. It's sort of like saying, "Yep, it's me. We're talking about me here, and I'm going to assign these variables accordingly because they're my variables." So that's what self does for us. It's a pointer back to our own object. Now here inside this definition for the initialization method, that's where we list our member variables or our data attributes. This is where we're going to add in the make, the model, the year, the mileage, those 4 things. The way we do that is we just simply do assignments. We will start with self dot and then make, and then give it some kind of initialization value. And we'll call this a Volkswagen for now. We'll do self again, and model is the other attribute, and I'll call this a Volkswagen GTI. That's what I drive. Let's say we want to create a year attribute. We can create self.year and give it an initialization value. And then finally, let's do mileage. And my GTI right now has got about that many miles on it, maybe a little less. So this is our class. This is all we have to do to define it. Remember a couple of things, that the private member variables here, or the data attributes, will always be defined within the initialization function, okay? That initialization function is commonly called a constructor. It's what we use to construct an object. Now, to actually create an object, we'll go into our main code then. And so here in main, what we'll do is we will call the constructor for car and simply assign that to another variable. So we'll do that this way. Let's say we want it to be called my car. We'll just do this. My car equals car, just like that. Now what this is doing, of course, my car is our object name. It can be my car, it can be GTI, it can be whatever variable you want to call that. And then what we do here is this is calling the constructor. So this is the class name, and this has to match this class name. And by definition, whenever we just call car with an open close parenthesis, it's calling the initialization function. So what this is going to do is end up assigning these 4 data attributes to these values, because these are the default values that we'll put in. Then what we can do is to access these elements, now that we've got my car established as an object, well, then we just call the individual attributes with .make, .model, etc. So we could, for example, in a print statement here somewhere, we could reference my car dot make, and it's going to give us VW. All right, let's shift and check out some code now, and this will make a little bit more sense when we see some code. Okay, here is our first attempt at creating a car class, which is right here, and then our first attempt at creating an object and then accessing that object's data attributes, make, model, year, and mileage. So here's exactly what we did. Here's our initialization method, or our constructor. Here are the 4 data attributes that we're going to go ahead and assign, and these are going to be all, these are the default values. Anytime we create a car, as we'll see in a demo next, it's going to have these values. So here in our main function now, this is our statement that actually creates, let me turn on line numbers. If you highlight a cell, just click on a cell out here and click L, it turns line numbers on. So here in line 11 is where we create the object itself. This car with open close parenthesis is going to call that class's constructor. Pretty straightforward. And then, as I mentioned, from this point on, with that object created, we can access individual elements just using the dot operator. So my car dot, and then we just list the data attribute. So here they are. Here's all 4. And when we run this, we see that we get the output here of what the car's attributes are. And here's kind of the format that we're using. I'm going to put the make first, and then the model, and then in parentheses, we'll put the year, and then we'll have a comma, and then the mileage, then the word miles afterward. So this is the most basic version of our class, but stay tuned. We have a lot of improvements to make on this, and we'll slowly go through all of those improvements here in this video and ratchet up the complexity for this class. All right, let me pause it. I'll go back to the whiteboard and we'll talk about the next way to improve this. Actually, I'm going to stay right here because here's the cell that is going to demo what we need to fix next. So here we have our same class, our car class. Now here we've got the same code for creating a car object, and we call it my car. Now, the beauty of object-oriented programming is that we can use our class template, it's the blueprint, to create as many cars as we want. And sure enough, here in line 15, we're creating a second car. This one's my car 2. And there we print out all of my car 2's attributes, all of the various attributes there. But when we run this, we see that, okay, it is creating 2 objects successfully, but they both contain the same data. And that's not unexpected. And that's because here in our constructor of the class, we told it, use these values for the default constructor. So anytime we create a car, it's going to use these values. Later, we'll be able to go change them, but we want to change this behavior so that, well, when we create a car right here in this code in line 12, and then in this code line in line 15, we want to give that object its own unique values. Maybe this one's a Volkswagen GTI. Maybe this one is a Ford Pinto. Maybe this one is a Dodge Durango. They all should have their own data because that's the beauty of object-oriented programming. Every object has its own data. So let's work on how we can fix this next. Okay, we're back on the whiteboard now. And what we want to do is we want to be able to use our own data when we create an object. It's that simple. So here's how we're going to do it. First of all, we'll look at, let me change the pen color here. We're going to make a modification to the initialization method here. And again, this is very commonly called the constructor. And you'll hear me say constructor a lot. We're going to modify the constructor just so that it can receive some parameters. and then use those parameters to do the correct initializations. Now, our goal here down in our main function is, well, when we create a car object, here's my car again, and we're going to call car, we want to be able to fill up the data between these parentheses and then use that data to create the object. So that's exactly what we're going to do. So, excuse me, we'll create some elements here, VW, GTI, put a comma, the year's 2015, and then another comma and 158,000. And this is just like calling any old function, and we're providing it with 4 arguments. So we're going to send these basically to this function right here. And now we just need to fill in this code here so that we've got alignment in both the number and the intended use of these variables. So let's keep in mind just what the order is that we wrote these in our intended constructor. And it's going to be make is first, and then model second, year third, and mileage fourth. So when we send those up, it's going to be very common to not use the exact variable name inside your class, because it could cause at least reader confusion. And at worst, if there's a name collision and the compiler can't resolve it, well, that'll cause a lot of issues. So it's very common to just use abbreviated variable names. So like the make, we can use MK for that. That'd be a good one. The model, perhaps MOD. The year, let's use YR. And then mileage, how about MIL, something like that. So all 4 of these variables that we, or arguments that we send up here, those get mapped to these 3 and 4, to these formal parameter names. And then we'll get to use those inside this function. And what will we do? We'll just simply say self.make equals MK. Self.model equals mod. Self.year equals YR, and self.mileage equals MIL. So all of these are being passed to these assignment statements. And from there, you can see, okay, now this object is going to contain its own data. So let's look at some code that'll illustrate this. And we'll see in this code how we can now use the same class to create different objects. Same blueprint, different cars. All right, be right back with you. Okay, this code has been updated now to do exactly what we intended, and that is, let me turn on line numbers. Here in line 13, when we create the car object, we want to give it these 4 pieces of data, and we want to send that up to the constructor. So we update the constructor's parameter list here to include those 4 variables. Now remember, you'll always have self, and self will always be first. Matter of fact, later we'll see when we add additional methods that every single method has got to have self as an argument. And that's just by definition, when Python was created, and this particular instance of Python was created, that's the way they decided to make the function actually just refer to itself, so that there's no confusion what object this method is operating on. All right, and then we just do our normal assignment statements there, like we saw on the whiteboard, and that does the trick. So here, line 13, we create that VW GTI, but look here in line 17, my car 2 now is going to be a Dodge Dakota. So when we run this, we see we get our output here, and we've got 2 car objects, and each one has got its own data, and the data is different. So this is a pure and easy example showing how we used one single blueprint to now create two different objects. Okay, students, let's talk about data protection and data hiding. One of the key features of object-oriented programming is that idea of encapsulation, which means every piece of data and every method is part of the class. Every object has their own version of data and their own version of the methods. And the idea is that we do that in order to protect the data. We have to hide it. Why would we want to hide it? Well, we want to make sure that no rogue data can go and access these class attributes illegally. We want them to only be able to access the data through our methods that we create. And it's like we're going to create a gateway and saying, if you want to come and look at my object, you can't just barge right in and say, what's the make and model? You have to instead request it through one of these methods. And if I grant it, well, then when you call that method, I will return the object's attribute to you. So that's how we're going to do it. The problem here is in our main problem, or in our main function, we saw that we had statements like this: mycar.make, mycar.model, mycar.year. That's directly accessing the data. And one of the attributes or key object-oriented programming principles is you can't. So we have to make this data protected. We have to make it hidden. We have to make it private. And that's so that we cannot access that data directly outside the class. We can access the data directly inside the class, so that's allowed. And we can access the data outside the class through appropriate methods that we'll create in time. So that's this idea of data hiding. So we're going to make it so that these are no longer valid Python statements because we're going to protect the data. Here, the big deal is, well, here, we're just calling mycar.model. What's the big deal? We're just going to print it. Well, it is a big deal because you could do a statement like this: mycar.model, and then do an assignment statement like that. mycar.model is a Dodge. And that is absolutely illegal. It's directly accessing the class or the data from outside the class. And not only that, it's altering the data. So this is the type of rogue code that we absolutely want to avoid. So how do we do that? Well, we do two things. The first thing we do is we create our data attributes inside the class as private data attributes, as private variables. How do we do that? Very simple. Instead of self.make inside our constructor, we're going to add 2 underscores in front of make. And that's all it takes to hide that data. That's all it takes to make that particular data attribute private. So we would say self.__make equals NK, or whatever assignment statement we do inside the constructor. And that's it. So let's look at code that supports this. Okay, we're back in our notebook, and we see here in our car class, we did exactly that. We said we're going to make the make, model, year, and mileage private. So we added these 2 underscore characters in front of each of those, underscore, underscore. And that makes them private. Now, this is the exact same main function that we had before, but when we run this, we'll see that, okay, it errors now. We got a bunch of errors here. The car object has no attribute named make. And that came about because right here in line 13, we're trying to access mycar.make, and it's giving us that error. There is no make. Why is it saying that? It's because make is now private. So this shows that, yep, our data is now protected. It's hidden. No rogue code from outside the class can access it. However, we need to still figure out, well, we're going to need to access it somehow. We need to do it legally. How will we do that? Well, we will create a series of methods inside the class. These will be part of our class now, that are going to be the authorized methods for accessing and even updating this data. So let's take a look at those next. And we're back on the whiteboard. Let's look at how we're going to access this data in an authorized fashion. And what we'll do is we'll create some methods. Now, there's going to be two types of methods that we will use to either access or update object data, and they're called getters and setters. We're going to start with getters. Now, getters are also called accessors. And the book calls them accessors and also getters, but every programmer in the world calls them getters. So I'll just use getters. And what they do is they get data. That's it. We're going to get object data by calling the getter function for it. Now, what do I mean by this? So what we'll do is we will create, inside our class, we'll create a second method. We've got the constructor, the initialization method, and we'll just add now another one that's called just getMake. It only takes one argument, self, but we don't have to send anything to it in our main function. It just, we're always going to have self as an argument inside of our class. And look at what is inside this code for the method. We're just simply going to return self.__make. It's that simple. We're just going to return the object. Now, I said before that the class and methods within the class can directly access the class data, and we're seeing that here. Because return self.make is directly accessing object data. But this method is part of the class, so it's authorized. We want methods outside of the class or we want calls outside of the class to use this method in order to get the make. Otherwise, they can't even get the make. So we'll just simply return self.make, and then to call this method inside of our main function, here's what we don't do anymore is this. We saw that mycar.make is going to try and directly access that object's attributes, and that's forbidden now, it's illegal. So instead of that, this is now completely forbidden. Let's just get rid of that. We'll just call the mycar.getMake method. So mycar. And there's our getMake. It doesn't take any arguments because we're just going to get that make returned to us, and we can do whatever we want then with the make. We can print it, we could assign it to a variable, we could use it in a function call, we can do whatever we want with it. So this will be how we access the data now in main. And then this is how we will define it formally inside of our class definition. Now here I just have a getMake method for the make, and you can see here, well, what about the model? Well, yeah, we have to make a getter for the model, and we have to make a getter for the year and a getter for the mileage. Essentially, every data attribute will need to have its own getter and setter method. So if we've got 4 data attributes, the car's make, model, year, and mileage, then we're going to need a getter for each of those, and we'll see here in a little bit that we'll need another round of functions to update the data. So let's look at some code, and this will make a little bit more sense in a second. Here's our code that's been updated, and you can see I've got a section here for the getter methods. And since these are all similar, I'm not going to separate them by spaces. I will just kind of clump them together since they all kind of look and feel the same. And there's the one we did for make, and it returns self.make. Here's the one for get model, get year, and get mileage. All of those simply returning self dot and then the attribute name. Of course, with the 2 underscores, because the official name of this attribute is __ make. If we happen to make this code here in line 13 and forget the underscores, it's going to give us an error saying that there is no data attribute named make. It's __ make. So let me restore those. Now, we've got our getters in place. All we have to do now, since we can't directly access the data here inside our main function, we're outside of the class. The main function is outside of the class. Here is where we then just simply call those getters. So here's mycar.getMake, mycar.getModel, mycar.getYear, and mycar.getMileage. And then there's just some formatting stuff over there. So that's how we create the getters. And then when we run this, we see that we get the exact same output that we had before, except now the data is protected. Now on this second car, let me show you here. That if I attempted to print my car2.make, this will draw an error. And sure enough, it did, because this car object has no attribute named make. It's called __ make. Well, even if I tried that, let's print my car2.__ make. We'll still get an error because there's no attribute. And it's saying that even though there clearly is an attribute, it's saying that because there's no publicly accessible attribute of that name. They're private. So that's how and why that will fall. So let me get rid of that code. So we've got nice clean code going. And then here is our full suite of getter methods for this class so far. All right, let's take a look then at the next thing, which are the setters. So I'll shift to the whiteboard for this. Hang on a second. Here's how we will tackle that problem. We're going to use setters. Now, what a setter is in Python is just a method that's going to help us update the data. The book calls setters as mutators. So accessors and mutators. Mutators means that you can use it to change something. Python objects are mutable, meaning they can be changed once they're created. So that's where mutators come from. But everyone in the world calls them setters, and I'll call them setters also. And what they do, they set data, they set values. So here's what we do. We will create a method that looks like this inside of our class, and every one of our data attributes will need a method like this. And we're just going to call it set mileage here, nice and simple. And this is going to take an argument. It's going to take an argument, let's say mileage, MIL. And that then we're going to use right here to set this private attribute here, mileage, to whatever was sent into the class. Now, it's important that we do that because maybe someone's trying to really mess with our class, and perhaps they send in a negative mileage, or perhaps they're trying to mess with it. That's why we want them to use this function, because our function we can create to protect the data against things like that. We could say, nope, we're not going to accept this mileage because it's negative. Right now, just for demonstration purposes, we will say that self mileage equals MIL for now. And then our call for that is just going to be this simple. mycar.setMileage is the method call, and we add an argument in there. That's going to be the new mileage. This new mileage then gets sent up to here, given the formal parameter name of MIL, and then we can use MIL within our method definition to do the assignment. So that's how that works. Let's take a look at some code now. Okay, here's a glance at our new setter methods. Each one of these maps to the data elements, okay? The private member variables, the data attributes, all of those names, make, model, year, and mileage. Now here's an example of, well, inside one of these update methods, we can put some error checking code in it to guard against bad data. And that's why we would want to use a setter like this, because if we just allowed rogue code to set whatever values they want, they could go in and set in, make and model to weird values and mileage to negative and the year to 4000 BC. And our object would say, okay, that's all valid data, but it's not. So we can put in code like this to guard against rogue data trying to edit that way. So here I've just got a simple if statement. If the mileage is greater than or equal to 0, then we'll go ahead and assign here in line 29, we'll go ahead and assign mileage to the self.mileage attribute. If it's negative, we're going to print out an error message saying, nope, mileage can't be negative. I'm going to go ahead and set it to 0. And then here's self.mileage being set to 0. So here in our main function, we're going to do the same thing. We're going to create the same car and print it. So we would expect to see the car's mileage as 158,000. But here we will call in line 39 the set mileage. And we're going to set a different mileage to it, this time 165. And then when we run it, we'll see here, yep, there's the second output instance, and we see that the mileage did change. Now I'm going to go rogue here. Let me try and set the mileage to minus 1,000. And our code should catch this and give us an error message saying, nope, no negative numbers. I'm setting mileage to 0. And that's exactly what we get here. Error, mileage can't be negative. I'm setting it to 0. And then our second instance of outputting the object data, it shows that it went to 0 mileage. So that is an example of using setters, again, also called mutators. And it demonstrates how they can be basically a guard against bad data. Okay, we'll look at another improvement next. Let me shift over to the whiteboard. And let's take a look at adding other methods to the class. Here's a method that we could use to update the mileage. This time, instead of saying, here's the new mileage, what I want to do is actually create a method to do that. And we want the method to receive the extra mileage. For example, if we drove 10,000 miles in this last year, well, let's update this car's record and add 10,000 to it. So this code is going to receive an argument, 10,000, and then add that to mileage. So how do we do that? Well, here's what we could do. Let me change my pen color a little bit. And we will create a definition inside of our class called update mileage. It'll take an argument because we will need an integer to add to the mileage. So let's just call this MIL. And deep in our code, then we can say that self mileage, let's not use that sign there, self.mileage is going to just simply be added to that mileage. Okay, so it's going to update by adding that to self.mileage, and this is now the total. And then our call for that would just be this code here, update mileage, and we provide an integer that represents the increased mileage that we're going to record for this car. Now, being good programmers, we can already see, well, okay, what if the user tries to enter a negative number, which is bad? We don't want them to be able to do that. Well, let's just put some guard code in here to kind of protect against that. So this would be in the case if MIL is greater than 0, then we'll go ahead and update. We can put an else clause in here, and then here give some type of error message saying, nope, can't accept that. I'm going to do this instead, something like that. And that's all we do to create, extra kind of class methods like this. We just simply create the framework, figure out the arguments, plumb the arguments, and then simply code the rest. So let's take a look at some real code for this. Hang on. Okay, here's our code for it. We've still got the same initialization method here. And this is the update mileage method that we're going to take a look at now, starting in line 11. So it takes a variable called val, and provided val is greater than 0, it's going to simply add val to mileage. Nice and straightforward. Here's that error message. If we do get a negative value entered saying, oh, mileage mileage update cannot be 0 or less. And then I also just output what they entered just for so that they know, well, what did they enter here? So we run it, and down here in line 43, this will be our new way to update the mileage. We're just going to add the new amount rather than the new total amount. So here we're going to add 12,000 miles to this vehicle, and then print it out again. So let's take a look at a run, and oops, let me fix a couple little things here. I think I want to put a parenthesis there and a parenthesis there just so that it looks better. There we go. And we can see here that the before picture was 158,000. The after picture is 12,000 greater or 170,000 total. So our code is working here. Now let's intentionally try and mess it up by saying, nope, I'm going to enter a minus 1,000, and this should not work, and it should give us that error message that we coded. So let's run this now, and yep, sure enough, there is the error message. It caught the negative number successfully, and now we protected the data by not, subtracting a number, because that's not what we do. We only add mileage. So I hope that helps explain just a real easy example of a class method that we can use to update or to operate on any of the private member variables or data attributes that we have. All right, the next thing to take a look at is we want to create a print function. In our object-oriented programming, we can create a method that's called __str___. What this allows us is it gives us this ability here. Rather than printing this giant print statement that we saw every single time we just want to print out the car's data, it's going to let us instead do this, print my car. And that's going to make it so much easier to output the car's attributes. And we don't have to repeat that code over and over and over. We just say print my car 1, print my car 2, whatever car we want to print, let's just print it. Now, what that str method is going to do for us is allow us to customize the output. We tell it exactly how we want it to output. Now, we saw before that the way I've got the print statement now is to print the make and then the model and then the space and then here the year in parentheses and then a comma and then the mileage. So what we're going to do is just take all of that code and put it into the str function. And what we do here is this is what we're going to create, just another method in our class. And it is going to return a string. And it's important that this string here can be a string that's going to be valid within a print statement. So if we've got a print, whatever we put here for return is going to be put exactly into the print parentheses. So if we're going to use output formatting, we need to return F and then the single quote, and then all of our formatting ending with another single quote. And that's the prescribed method to do this. So let's look at some code that's going to demonstrate this, and it'll be a little clearer when we do. We're back in our code now, and here this code is going to add that str method. So we just put it right here. I'll take this space out just so we can get a little more on the screen at once. And here's the new print method, the new, basically a string method. It takes self as an argument, like always, and it's going to return. And this should look familiar because this is the entire guts of the print statement that we had above. Here is all of that guts from the F all the way through the closing single apostrophe. And just for, let me paste that. Oops, let's not do that. Did I cut that? There we go. Let's copy that. And then let's print it right here. And you can see that this F string here is exactly what we put in here, except remember that this is a method of the class, so we don't have to use get make. We can just say self.make. Same thing here. We don't need to use get model because we're already inside the class, so we can just use self.model. So returning this, what happens then is this entire string then gets substituted and put in here for when we print my car. So this again gives us the capability. Oh, and let me show you here that I've got this string set up to be the exact same thing that we did before. Here's the make, and then a space, then the model, then a space parenthesis. Here's the year, close parenthesis, comma, then the mileage, and then the word miles. And we'll see that here in line 40, the print my car, that statement works now. Not only that, we can update the mileage, and then rather than printing that giant print string again, we can just print my car again, and it's going to give us the new mileage. So let's update this. We see that the mileage did update. We got the same output, except our code is so much sleeker now. You know, the previous code, every time we wanted to print a car out, we would have to print out this giant statement, but we no longer have to do that. It's like we made a miniature print function. Next up, we want to alter our main function. So rather than hard coding all of this great object data into our program, we want to read from a file. So let's suppose that we've got a text file, let's call it cars.txt or data.txt, doesn't matter. And suppose it's got these data elements in it here. It's got two records, one for the VW GTI, and then there's another record for the Dodge Durango. And we see here how every record is comprised of 4 data elements: the make, model, year, and mileage. So let's suppose that we want to read from this file. Well, we know how to do that. We'll create an in-file object. Here I've got the number of cars set as a constant for 2. And then we will just use a for loop. We'll just run this for loop that number of times. And you can see here that we've got various in-file read line statements. It's just read line is going to read one line at a time. I also include the rstrip method at the end of it so that we strip out that new line character. So make is just simply going to be infile.getLine.rstrip. Model will be the same thing. For year, we do the same thing here, except we cast it as an integer. And then mileage, we'll have to do the same thing. We'll have to cast that as an integer also. Now then, here's what we do. We create a temporary car object, just called temp. And we use those 4 variables that we just read into, make, model, year, mileage, and we use that to create our temporary car. Now that we've got that car that's temporarily created, then we can output it. So our goal here when we run the code is that we should see all of the car data from the car.txt input file properly populating an object that we create, and then we're going to output it for validation. So let's look at that code. Here's our cars.txt file. I've got 5 cars in it. Here's the GTI, here's a Durango, a Tacoma, a Plymouth Reliant, and then a Chrysler PT Cruiser. Who buys those? So we've got these 5 cars, and we want to modify our code, so it's going to read all 5 into car objects and then output them. Here's just a repeat of those of the data elements that are in the input file. And here, the beauty of this particular code is that we haven't altered the class at all. The class is exactly the same as it was before. We didn't alter anything. So we're going to be doing our coding here inside of our main function. So I've got a constant. Line 58 is setting num cars to 5. And then here in our main function is where all the magic's going to happen. First, we create the in-file object. Here we run a for loop, num car, so this will run 5 times. Note here that I don't have an index variable assigned inside the for loop. I just have the underscore character. And of course, you can do this with for loops in Python if it's ever the case where the index is just not needed. We can certainly put an index variable in there like I, and it's not going to matter. Of course, our for loop doesn't use I at all, so let's not create a variable that we're not going to use. All right, and then our first 2 read operations are going to just simply read the make and model. We've got rstrip to take out the new line character. We do the same operation for year and mileage, except we cast the input as an integer. So we just int, and then the whole thing is put in parentheses. Here in line 58, we create that temporary car. And then here in line 69, sorry, that was 68 and 69. Here in this line, we're going to just output the temporary car. And you see here, we got all 5 of these objects successfully output. So we know that our code is working, and we know that the input operation is working, and that it's properly populating this data into the car objects. Now, this is all very well and done, but wouldn't it be just magic somehow if we could store all of these cars? Here we're not really storing them. And matter of fact, if we were right here in our main program to print out temp car, we would just get that last car repeated, and all of the other temp cars that we had made are actually gone. So let's put them in a container. And this is going to be a very common thing in object-oriented programming, where we will have a container of objects. In this case, we'll use a list. We'll create a list, and rather than this list being comprised of integers like 5 and 6, and a bunch of integers in a list, we're going to put cars in a list. Every list element is going to be a car object. And because it's a list, we can then iterate through the list using a for loop, a while loop, whatever we want to do. We can also iterate, or once we're in a for loop, we can use an index variable to access specific cars. So like if we make a list that's named cars, then we can say cars sub 3 is a certain car, and we could print out that car if we wanted. So let's figure out how we can do this. I'm going to pause it here, and we'll go to the next part of our code and show how we can start to create this list that's going to become a container for our car objects. Here's how we'll accomplish making a list of objects. We're going to create a container for these cars. So here's the pseudocode on the left here. Our first step is and again, all of this coding is going to be in our main function, not in our class, because our class is only concerned about creating a single car object and giving us access properly vetted through to that data, give us the methods, etc. The car class does not care about what kind of container it's in. That's a job for our main function. So all of this coding is going to be in main, not in the class. The first thing we'll do is create an empty list. We know how to do that. The second thing is we will loop, and we just did that. The third thing is we'll read all of the data, which we just did. The fourth thing is we will create a temporary object with that data, which we already did. And we're basically going to just add now an append statement that is going to append that temporary object to the list that we created. So over here is some sample code showing how to go about doing this. Here is how we create our empty list for cars. This code is all the same, all the same, all the same. And then we're just going to call cars.append. And whatever temporary variable name, that's what we send in as an argument. And it's going to then append that car to this list right here. Now we have to be just mindful of what we name these. Here I've got this list named as cars, C-A-R-S underscore, all lowercase, especially starting with a lowercase letter. This is going to denote that this is a variable. It's a variable that happens to be a list, but it's a variable, and it's not anything related to the class. So this is just the container for class objects. That's as opposed to if we use capital C-A-R, then that is pertaining to the class objects itself. That's the class definition. Now, if we were to use a for loop, and we will to output this car data, I'll show you that code here in a second, we might use a variable CAR, all lowercase. And this is yet another completely different variable from cars and completely different entity from the class name car. So these all look and sound the same, but they all have very different purposes and different functions in our coding, and we need to make sure that we certainly understand them. So let's look at the code now that is going to help this out. Okay, looking at our code, again, we're in the main function still. Here's the first thing we do. Let me get some line numbers going. Line 42 is creating that empty list. Oops, let me not move that. These lines are all the same from the previous code, and it's just simply reading the records in the input file. Here's where we create that temporary car object based on the variables that we read in. So temp car equals car. That calls the constructor, and it sends all 4 of these arguments into the constructor as its parameters. And then here's where the magic happens. In line 50, we append that temporary car to our Python list. So cars here is going to then just grow in size. And ideally, we will see 5 cars in our collection, because we know that over here in our cars.txt file that we've got these 5 cars. Now look at our print statement. For car and cars, print car. That's fun to say, but let's make sure we understand what these entities are. Now, car is just a programmer defined anything. It can be I if we want it, and it'll still output just fine. But a common convention is, well, cars is this list that we defined here in line 42. And it's common, well, what is cars? Well, it's a collection of cars. So we'll use a car here, singular, for car and cars, and we'll just print the car. And that gives us then access to the print statement. This then sends this particular element up to the str function, and we get those printed out just fine. So I hope that this helped in our first stab at object-oriented programming. We're just going to spend another week next week looking at the rest of object-oriented programming. Next week is a little glance ahead. We'll look at things like separating our code into actual modules. That's a very common thing in object-oriented programming, and we can do that here in with the Jupyter Notebook. Well, this week we created a list of objects. Next week we're going to create, are you ready? A dictionary of objects. We'll also look, how do we pass an object to a function? That's quite easy. We just pass it, but we'll have some code to demo that. And then we'll also look at the ability to overload a constructor. What that means is we can create a constructor that is going to be able to take 0 arguments or all 4 arguments. So this will make a little bit more sense next week. All right, that's it. I hope this code helps, and good luck on the lab assignment, and good luck, everybody. And if you made it this far, congratulations. I would be glad to send you the Jupyter Notebook with all of the demo code that we saw in this video. All you have to do is email me and ask me for the demo code. All right, thanks, everybody.